There are two parts to an exponential expression. The larger number is called the base, and the smaller number is called the exponent. An exponential expression is a shorthand way to write repeated multiplication. So 4 to the 6th power means 4 times 4 times 4 times 4 times 4 times 4. We have 6 factors of 4. Now writing the expression this way is called writing it in expanded form. Sometimes we write expanded form to get a better idea of what our exponential expression really means. We're going to look at some properties that we can use when working with exponential expressions, but we're also going to look at some common misunderstandings there are about using those properties. Here's the first common misunderstanding, that something like 3 times 2 to the 3rd power is the same thing as 6 to the 3rd power. Now, if we believe that, then we could say that 3 times 2 to the 3rd power is equal to 216. It definitely isn't, and here's the reason why. If we think about 3 times 2 to the 3rd power, that means 3 times 2 times 2 times 2, not 6 times 6 times 6. So 3 times 2 to the 3rd power is really equal to 24. The mistake was made in thinking that we should multiply the 3 times 2 before we apply the exponent. You might be reminded here of order of operations, which says we need to apply exponents before we apply multiplication. Here's the first property of exponents we can look at. A to the m times a to the n equals a to the m plus n. In other words, if we're multiplying two things together that have the same base, we can rewrite that by just adding the exponents together. Here's an example with numbers. 4 to the 2nd power times 4 to the 3rd power equals 4 to the 5th power. Now, why does this work? Well, if we think about expanded form, 4 to the 2nd power means 4 times 4, and 4 to the 3rd power means 4 times 4 times 4, which means we're multiplying 5 factors of 4 together, and that would be 4 to the 5th. So when we add the exponents, we're really just counting up all of the factors that we're multiplying together. There's a couple of common misunderstandings with this property. The first common misunderstanding is thinking that we should multiply the bases together. So 2 to the 3rd times 2 to the 4th equals 4 to the 7th? Well, that's not true. Remember, the base is telling you what number you're multiplying together repeatedly, and if you're multiplying 2's together, they don't suddenly turn into 4's. So 2 to the 3rd times 2 to the 4th should really be 2 to the 7th power. Another common misunderstanding is to think that we could multiply the bases together and say that 2 to the 3rd times 3 to the 4th is 6 to the 7th. Remember, the base won't change when you're using this property. The base is simply saying what number you're multiplying together, and the number you're multiplying isn't changing. The next property says a to the m divided by a to the n equals a to the m minus n. In other words, if we're dividing and the bases are the same, we can rewrite that by subtracting the exponents. So for example, 6 to the 7th power divided by 6 to the 4th power is going to be 6 to the 3rd power. Now this works because if we think about the expanded form of both 6 to the 7th and 6 to the 4th, you can see that we have some common factors in the numerator and denominator of the fraction. So we could cancel out those common factors. We're really just finding factors of 1 in our fraction. And that would leave us with 6 times 6 times 6, which is 6 to the 3rd power. Now, if you stop and think about it, we had 4 factors of 6 in the denominator, which we paired up with 4 of the 7 factors of 6 in the numerators, which left us with 3 factors of 6 in the numerator. A common misunderstanding with this property is to think that if we're dividing and the bases aren't the same, that we can divide the bases. Once again, that isn't true because the base is telling us what number we're multiplying, and we're not going to be changing the base. We're simply going to be simplifying a fraction by finding the same factor in the numerator and denominator. The next property of exponents says that a to the m to the n is a to the m times n. So this property is saying if we have something raised to a power raised to another power, we can multiply the powers together. So 4 squared to the third power is going to equal 4 to the sixth power. Now this works because we know that if we have an exponent, it tells us that we're repeatedly multiplying something. So 4 squared to the third power means we're multiplying 4 squared times 4 squared times 4 squared. That's 3 factors of 4 squared. And if we think about the expanded form of each of those 4 squareds, you'll see that we do have 6 factors of 4. A common misunderstanding with this property is thinking that if we have a power to a power, that means that the powers are being used as a base and an exponent. Well, that simply isn't the case. We're not squaring the 4, we're squaring the 2 to the 4th. The next property of exponents says that if we have a to the n times b to the n, that's a times b to the n. Now the important thing here is to notice that although the bases are different, the exponents are the same. So in this case, if we have 3 squared times 4 squared, we could rewrite that as 3 times 4 all squared, which would be 12 squared. This may look a lot like the property we had that said if we're multiplying and the bases are the same, we add the exponents. But what's important to notice here is that the bases aren't the same, but the exponents are. Now if you think about what's going on with something like 3 squared times 4 squared, we can look at expanded form for each of those, and then realize that because we have factors that we can rearrange and regroup, we could rewrite this as 3 times 4 times 3 times 4. In other words, we have 2 factors of 3 times 4, which is 3 times 4 squared. A common misunderstanding with this property is thinking that we're going to multiply our bases and we're going to multiply our exponents. If we have something like 3 to the 5th times 4 to the 7th, the bases aren't the same, but neither are the exponents. So this property will not apply to something like this. The next property is pretty short and sweet. Anything to the 0 power is 1. Well, anything except 0 to the 0 power is 1. So, for example, 3 to the 0 power is 1. Now this one's easy to understand if we look at some patterns. So think about something like 3 to the 3rd power. That means 3 times 3 times 3, which is 27. And 3 squared means 3 times 3, which is 9. You'll notice that the exponent here is a 1 smaller than the one we started with. And the relationship between 27 and 9 is that if we divide 27 by 3, we get 9. So if we decrease the exponent, 3 to the 1st, that would have to equal 3 because we could continue the pattern and divide by 3. So now we get to 3 to the 0. Well, 3 to the 0 has to be 1 because if we continue the pattern, 3 divided by 1 is 3. The most common misunderstanding with this property is thinking that anything to the 0 power is 0. We know that's not true. 8 to the 0 power would have to be 1. The next property tells us what the meaning of negative exponents is. A to the negative n power is equal to 1 over a to the positive n power. For example, 3 to the negative 2 power is 1 over 3 to the positive 2 power, or 1/9. Now this can also be seen through patterning. So remember we said 3 to the 2nd power was 9, and 3 to the 1st power was 3, and the pattern we're seeing is that 9 divided by 3 is 3. 3 to the 0 power is 1, because 3 divided by 3 is 1. If we continue the pattern with the exponents, 2, 1, 0, well, the next exponent has to be negative 1. And if we continue the pattern with the numbers 9, 3, 1, 1 divided by 3 is 1/3. And continuing the pattern, 3 to the negative 2 would have to be 1/3 divided by 3, which is 1/9. And after all, 9 is the same thing as 3 to the positive 2. The most common misunderstanding is thinking that negative exponents mean negative numbers. They don't. They mean reciprocals. So 3 to the negative 2 has to be 1 over 3 to the positive 2. Now just a quick word about exponents and place value. If we have a base 10 number, like 5,827, we know that each of those digits are in a place. So the 5 is in the thousands place, which is the 10 to the third place. The 8 is in the hundreds place, or the 10 squareds place. The 2 is in the tens place, or the 10 to the first place. And the 7 is in the ones place, or the 10 to the 0 place. Which means we can also write this number in expanded form using exponents. 5 times 10 to the third plus 8 times 10 squared plus 2 times 10 to the first plus 7 times 10 to the 0. Now thinking about the place value can also help us answer questions like this. 400 is how many times larger than 4? Well, since 400 is 4 times 10 to the second power, we know that 400 is 10 to the second times larger than 4, or 100 times larger than 4. So one last thing. We've talked about lots of properties of exponents. Sometimes we can apply those properties to expressions that don't look like we can use the properties to simplify them. For example, 3 to the fourth times 9 to the third. Now we do have a property that says if we're multiplying and the bases are the same, we can do something, but the bases are different here. And we have a property that says if the exponents are the same, we can do something, but the exponents aren't the same here. But maybe we can rewrite this so that it fits into one of those properties. For example, if you look at the 9, 9 is the same thing as 3 squared. So now at least we have everything written with the same base, and we can start to apply some of our properties. So 3 squared to the third power is the same thing as 3 to the sixth power. And now we're multiplying, and the bases are both 3's, so we can add the exponents and have a final simplified result of 3 to the 10th power. How about this one? 2 to the 20th plus 2 to the 20th. Now we do have a property that says if we're multiplying and the bases are the same, we can simplify. Or if we're multiplying and the exponents are the same, we can simplify. But in this case, we're adding. So we can't apply any of the properties we've already talked about. But we can say we have a 2 to the 20th plus another 2 to the 20th, which means we have 2 to the 20ths. And now if we think about that first factor of 2, that's the same thing as 2 to the first power. So now we're multiplying and our bases are the same, so we can add our exponents together and get our final simplified result of 2 to the 21st power. So be very careful with exponent rules. They do help us simplify expressions, but it's really easy to misapply them. So just be very cautious and think about why what you're doing works.